I'm going to introduce Everett Moseley, Director of Artificial Intelligence at Bell, and Ali Jilani, Senior Product Manager at Bell. Thank you.
Awesome. All right, good day, everyone. I really wanted to use this as an opportunity to talk a little bit about the work that we're doing real time today to provide value to customers. So just to kind of start off, there's been a lot of discussion on using AI, looking at LLMs and trying to essentially generate value from that perspective. However, for most businesses, real value is actually generated at the RGU level, right? And so, for us, one of the things that we spend a lot of time on is really making sure that we're able to kind of focus on getting value at that level. Really creating models and scores to be able to generate offers that provide value to customers at the level of 1 in the most real-time way possible. And so today, what we're going to be doing is really walking you through our entire arc, from where we started using batch models to then using conditional models and now doing work real-time to be able to provide value at the level of 1. So Ali here is going to be walking you through our full step-by-step flow, and then at the end we'll be talking through some of the considerations that we should actually have when making a decision. Now I'll say this before we go. This is not like a fun project. This is actually generating millions of dollars of value for Bell, and so we take it very seriously, and it's definitely something that is a part of our critical business process flow. Go ahead, Ali.
Thanks, Everett. There's 2 things I want to start off with. My goals for this presentation are you walk out with an understanding of which use cases in your business can leverage real-time data, and then also a deep technical understanding of how we at Bell actually went about implementing this. So, I think maybe this clicker doesn't work. Is there? Oh.
This at the top, maybe.
Okay, there it is.
There you go.
Okay. All right, so quick lay of the land. Obviously, when we're talking about batch modeling versus real-time modeling, batch modeling can encapsulate tabular models, running LLMs in batch, or NLP models. So in this conversation, we're not really talking about the construct of the model itself, but more about the trigger time. When is it running? Is it running on a daily schedule, either daily, weekly, or monthly? Or is it running based on an event that happened with a certain customer? So at Bell, similar to many of the companies you guys are at, we started with our batch propensity models. So we looked at what are some of the things we want to understand or predict about our customers, in particular things like churn. When are they going to leave? What is their propensity to buy? What is their propensity to hardware upgrade? And to build these models, we looked at the regular tabular data that we have, things like tenure, things like how much they're paying monthly, what is their promo, when will their promo expire, et cetera, et cetera. And the way we set these tabular models up is that we have all of that customer data, we process it, it operates at midnight, and that next day we have the score to use for that customer, whether we're evaluating what offer to give them based on churn, or whether we're evaluating if we should pitch them, an extra sale on a cell phone. There's a few things that are missing from our data, especially when we start diving into the customer use case. So I want to introduce John here. John is a Bell customer. He wakes up one morning and he looks at his app and he says, my bill's looking a little higher than I maybe wanted. Later in the day, John opens up the browser and he goes to Bell's Change My Rate Plan flow. He's looking at what plans are available, and then in the afternoon, John goes into the mall, walks into a retail store, and starts to understand what offers Bell has and what offers the competitors have to serve him for his cell phone or his internet. When we're using batch models, all of these data points are missing, right? At 12 o'clock midnight, we see John. He's a happy customer. We understand John's been with Bell for 12 months now. He's on this plan, and everything looks good. Within the matter of the day, there's a bunch of signals that we're missing. John opened up his app. John looked at, rate plans. John went into the retail store. Those signals don't catch up until the next day. So until that next batch cycle runs, we don't know all of these data points that happen with John. And that's kind of where our blind spot is. And specifically in telco, our customers move really fast, right? So if we're not seeing all of these actions that John's doing, it's a big gap for us. We're seeing it. Yesterday he was fine, and then today all of a sudden, it's a really big problem. What is the first thing that we deployed to fix this? The smallest, easiest fix that we created is conditional batch models. So if we go back to John's use case, for example, we know everything about John at 12, and then he does a couple different interactions with us. A conditional batch model is just pre-computing that action, right? So we're saying, okay, let's create a did our customer go to the retail store conditional model. So we take all of the features of John, and then we pre-calculate, let's assume John's gonna go to the retail store, and then we generate a score, right? So now when John walks into the retail store, we actually have a batch score that tells us what John's churn propensity would be if he walks into a retail store today. But there's still a few gaps there. Number one is the sequence. That conditional batch model, which identified John went into the retail store, didn't see that John also opened up his bill in the morning, and then in the afternoon was looking at rate plans. It missed those gaps. And what we found is the combination of those signals is really impactful when we're trying to understand John's churn propensity. So it's not just about, John's features or the fact that John went into the retail store. It's about John's journey that day. It's about the fact that he did a bunch of things which we can interpret to understand, hey, this guy is really looking to leave today. So that's kind of where we made the leap into real time, right? No longer are we trying to identify everything about John the night before. We're trying to actually understand John the moment things happen. So as he looks up his rate plans, can we change our understanding of John's churn propensity? Can we change our understanding of John's sales propensity, etc.? So I wanna dive you guys through the technical architecture on how we actually built this, so you have something to take away and ask Claude tonight. So first off, let's start at the top, right? So at the top, all of our traditional tabular batch data is in BigQuery, right? We're a GCP shop. You can substitute this with any data storage, mass data storage that your company uses. And the first thing that we do is we load the features that are important for the model into Cloud SQL. So Cloud SQL is just another Google service, which is a little bit quicker. It decreases the latency. Querying directly from our data lake, our big data infrastructure is slow. So we take the features that we care about. Let's say we're doing churn propensity. We take tenure, we take how much he's paying, we take his promo. We preload those features into Cloud SQL, right? Next, we have our live events streaming through Kafka. So Kafka is just a message broker. It's just passing messages. But the piece here that isn't fully kind of articulated, which will also be a challenge for you, is actually getting your endpoints to stream these events. So we've built the infrastructure for our app, right? So if you go on your Bell app and you go on to the rate plan flow, our app is then streaming that event to our machine learning pipeline via Kafka that says, hey, John looked up rate plan flow. Hey, Everett walked into the retail store. Hey, Ali, called into the call center. So we've built the infrastructure to pull all of those events streaming through Kafka to then be ingested by our inference pipeline. And for the technical folks there, our inference pipeline is just essentially a data flow job in GCP, where we're pulling the batch features from Cloud SQL, we're pulling the real-time features from various Kafka streams based on where they're coming from. And then there's one more component, which is Redis, which we're actually caching our real-time features. So the way this works is, let's say the first lookup of the day, John at 9 a.m. on his phone. We pull John's batch features, we get the lookup from the app, and then we pass all of those to our churn model, and then we get the score, right? We know John's churn propensity is in this case, X. But what we do is we still need to save that data point, that app lookup, because that app lookup doesn't exist in Cloud SQL, because that didn't happen yesterday, that happened today. We save that app lookup in Redis, just like a temporary storage. We're caching that app lookup. So now when John looks up on retail, we do the same process. We pull all of John's batch features, we pull in the retail lookup, but then we also pull up the app lookup. So now we know, okay, all of John's features, John also looked up on the app earlier today, and now in this moment, he's looking up in the retail store. We pass those to our model, and then we get significantly more accurate understanding of John's churn propensity. So in this case, just for example's sake, when John opens up the app later in the day, we are able to track everything that he did. And from the night before, John had a churn propensity of 0.34. Moving forward, at this moment in time, John has a churn propensity of 0.61.
And, sorry,
Go ahead, Everett.
One thing to add, in the Redis store, we're actually using a sequential events type infrastructure. What does that mean? It means that we're actually taking into account the sequence of events of all the activity that happened that day to be able to then model, as each event happen, how does the likelihood of churn actually increase during the day? Go ahead.
No, that's a great point. So the one thing that I just want you to be cognizant of as you're engineering this system in your own companies is like data latency is so important, and making sure all of this data is coming in at the right time, in the right moment. So these micro things like pushing our batch features into Cloud SQL, it may not seem like much, but these give you those fractions of seconds, which are super critical, as you'll see in the next slide, to start actioning then on these real-time outputs. So the next piece is, all right, we got our real-time output from our model. What do we do? How do we actually utilize that? So the number one thing we do is our real-time pipeline pushes our output to another Kafka topic. And now we've engineered our end stream systems to grab that score and then action, right? So now we're able to do things like when John opens up his app, we know everything that happened, and we can preload an exclusive offer for John. Or maybe we see John looking at his bill, and we see that he's notified that his promo is expiring. Maybe we actually send John a note. Hey, by the way, here's an extension of your promo by an extra 12 months, on us. We're able to do these live actions. So we've processed the data in real time, and then the second portion, which is equally important when you're engineering, is can you action that in real time? So we're pulling that data again from Kafka, and then we're able to serve it to multiple interfaces based on where John is at that moment, including things like, maybe when Everett walks into the retail store, the agent looks up Everett's account. We can even surface that to the agent's screen so that the agent has something to win Everett back with.
I think one key piece of information that we're actually leveraging that we've not really spoken about a lot here is actually the speech utterances. Because we now have the ability to use LLMs to be able to understand the customer sentiment, we're now also feeding that as an additional variable into our models real time to be able to understand, okay, how upset is this person really? Are they really, really upset, or are they just upset? And that helps us with understanding the types of offers that we'd need to release.
Actually, Everett makes a really good point. I should have mentioned that because it's literally my product. But like one of the streams that we've been able to engineer as part of the incoming real-time streams is actually utterance by utterance understanding of what the customer is saying. So the customer's on the call, and we're actually passing every sentence that the customer is saying to a Kafka stream to ingest. How we use that, whether it's NLP, whether it's LLM, we've done different things, but it's a super critical portion of our pipeline, which is it's just giving us richer and more powerful data to then use in real time. The last piece that I just want to cover, and then I'll hand it off to Everett, is like really thinking about in your business, like, why does this matter, right? For us in telco, I just walk you through, the John use case. And it matters because a lot of our customers look like this. They don't engage with us regularly, but when they do, something's happening, right? And when they act really fast, right? They see our offer, they see Rogers, they see TELUS. Like, we don't have much time to kind of win their trust, win them back in that moment. And the stakes are high. If we don't satisfy, if we don't service the needs of our customer effectively in that moment, likely we're going to lose them. I'll hand it off to Everett now to kind of talk us through a little bit more about how you can think about real-time modeling in your business.
Thanks, Ali. So I think the key point here is this is not just an AI solution. It's actually a real-time business operational problem that we're trying to solve, right? And so the question that we should probably ask ourselves is, okay, what are the scenarios under which we should actually consider doing something like this? Because there's not really a playbook out there that you should follow, and so we decided let's just package it up based on what we've learned the hard way. So there are really three factors. The first one is understanding the customer behavior, okay? Really, you got to start with the customer, not necessarily the architecture. So, as an example, we talked about churn here. For a customer that you're modeling churn, you really need to understand what are the key features, what are the key actions that drive customer behavior to be able to churn. So that's one. Two, you need to then be able to understand, okay, if all of these signals, let's say I have 100 of them, which one of them is going to incrementally make a huge difference for me intraday? And if that activity, if that decisive intraday activity is really driving a significant lift in churn, then this is definitely a key factor that you should consider. So understanding the customer behavior is really critical. I'm not saying that for every single scenario, if you have an intraday lift, then you should go ahead and do it, which will now bring us to factor two, which is understanding your capability. Okay, so as Ali mentioned, we have data coming in. So yes, you can score your customers from a churn standpoint intraday. You're able to tell whether or not they're shifting from a .3 to a .6 in terms of churn, which is a huge lift. But the reality is, if you're not able to execute that on the tail end, you're still gapped. And so you really need to understand, okay, yes, I'm able to get this data real time. Yes, I'm able to generate a model, but I also need to work with a business partner, someone in IT, to be able to say, okay, can I push information to the customer real time to be able to save them? And so this is a key consideration for us. Whenever we're thinking about implementing new things at Bell, we always ask ourselves, okay, how fast can I get the information? But also, how fast can we execute, right? So key consideration there. And then finally, this is the one that I think we live and breathe by. ROI. Is it worth it? Is the juice worth the squeeze? Right? And so it always comes back to, am I spending too much on the pipeline infrastructure? What about feature freshness, monitoring and alerting? And then, I think it was mentioned in the previous session about data storage and about making sure that you're not storing too much data for real-time purposes. These are all factors that we take into account when making a decision like this. Now, at the end of the day, we're measuring the lift, so the incremental benefit of a customer taking an offer relative to these costs to be able to make a decision as to whether or not it makes sense continuing down this path. And so, the final takeaway here is really start with batch. If you're not doing real time today, start with batch, build your way to conditional, and then eventually you can get to real time. You have to start somewhere, You can't just go real time immediately. So quick summary. Today, we at Bell, we're now leveraging real time for a number of use cases. But the biggest value add for us is on the loyalty side of the business. Like, that's where we see the biggest value, because now we're using these models to be able to understand our customers better and using that to actually drive value. Our arc started very simple. It started as batch, we went conditional, now we're real time. And we're not doing it for everything. If the ROI isn't worth it in some scenarios, we're choosing to remain on batch because, again, it's not worth it. So I think these are the few things I'll leave you guys with and open it up for questions. Oh, we're right on the dot.
Thank you.
Do you mind elaborating on what your offer engine is? What are you using? Is it a proprietary solution or a third-party solution? Or
So I'll comment on that. We are using proprietary software in conjunction with out-of-the-box tools. So today at Bell, what we've done is we've created real-time, what I would call a real-time offer engine, and that's kind of stored in Vertex AI. But then the management of these offers are done in another application that we have in-house, that we've purchased. It's called Unica. It's an old product, but still works very well.
Yeah, so it's something to bring in data to your predictive model. But then it's another thing to know what information are actually good for the model to make a better prediction. So I'm wondering, in your company, how did you come up with the predictive model? Is it that you have statisticians working with you guys? You have a team that does research and come up with the researches of like how good their predictive model is, and how big would the mathematician team, like how big is it? Is it PhD level people, or how does it work?
Okay. So I'll answer the first half of this question.
Okay.
And then Ali, I'd like you to talk through the day-to-day, okay? Sure. So to answer your question, yes, we have a huge team of people who we've kind of divided into what we call data scientists, and then we have AI engineers, okay? The data scientists, their job is very clear. It's feature selection, making sure that we are actually getting incremental model lift, making sure that between features, there's not too much correlation, which then creates a degradation in our model. So that all of this is happening within the teams today to be able to create what we call our AI feature factory, which is essentially, for want of a better term, just a feature store of all the factors that we consider important for a model. Taking from that feature store, we then create a model factory, which is then now powering this stuff real time. So that is like what I would say the day-to-day operations in terms of who is doing what. But maybe, Ali, I don't know if you'd like to comment on some of the elements that you guys use on RTV.
Yeah, I think you covered it pretty well. I'll answer a quick one of the points of your question. You asked, like, how do we identify which of the features are valuable? It's both like the business who are operating this know what are the interaction points of the customer where they see the most churn risk, but we also identify them ourselves, right? When you build a batch churn model, you'll see, hey, the person who went to the retail store, that lookup indicator is like super highly indicative of churn, right? So we look at those types of things and say, okay, national retail lookup, when you're looking up in a store where other providers are also being sold, that's like the highest indicator of churn. We need a way to pull that in real time, so when you get looked up at a national retail center in real time, we can then act. I don't know if there's another portion of the question.
No, you nailed it.
Okay, cool.
Yep.
Hi. Yeah, great presentation, thank you. I've worked in telecom before, so I can relate to the use case you shared as well. Two quick questions. One is, you spoke about ROI for real time. Are you able to share what sort of ROI benefits or lifts in your data you saw here, in the results you saw here? And secondly, when we talk about retention and real-time offers, how do we control for bad behavior as well? In the sense, clients can get used to the fact that I just open the mobile app, I visit a page, and I got a great offer last time, I'll do it again. Have you seen that sort of behavior come through at scale?
So your first question, I'm not at liberty. I specifically anticipated this question would come at some point. I'm not at liberty to disclose it, otherwise we'd have put it on the slide. What I will say is, because we're seeing benefit from this, we're continuing to do it. We're seeing significant benefit, especially when you get more and more targeted in certain segments of our business. We're definitely seeing significant incremental benefits, and as a result of that, we're investing more and more there. So I hope that answers the first half of your question.
The second half, do you mind if I take a
Yeah,
second?
go for it.
So the second half of your portion is like, how do you insulate for abusers, essentially people who are trying to manipulate the system, right? So there's a couple things that we do. We have a deeper understanding than just like utilizing the features and like outputting the offer. Like we know, hey, this customer called a while back and they already got like a really good offer. Like, are we gonna race them to the bottom? We have more intelligent decision making in like the actioning portion, like that offering engine portion of the slide, than it alludes to. It's not really a dumb like, okay, this person has a 60% churn propensity, we should give him everything. Because often, like we said, like, you know, Everett brought up the fact that we have, you know, speech utterances. Sometimes irate customers are irate because they're trying to negotiate and trying to get you to the bottom, right? So we also have enough data that we can almost tell who's irate customer trying to race us to the bottom versus who is a loyal customer who's currently just dissatisfied with their service. So we utilize kind of historical events and then logic as a combination of those to actually come up with that end result.
Thank you so much, guys, for such a
Thank
great
you.
presentation and fantastic case study. I'm sure everyone really enjoyed it. Can I get a round of applause for them as well?
Thank you.